Welcome to Knowledge Chat channel. Today in this video we will be discussing about how to reduce a complex circuit into a simple circuit. Here in this video I will be explaining with three different examples. I will be taking three different complex circuits, and finally it will be reduced to a very simple circuit. So the importance of this video is mainly that is nowadays core jobs are playing a very vital role, and you know that circuit reduction plays a very vital role in many of the industries, that is mainly in core industries. So I have taken an opportunity to make you understand how a complex circuit can be reduced into a very simple circuit. So let us go into the topic. So the first one is, so here you can see that this is a circuit. So initially I will start with a slightly complex circuit. Okay. So this is so the question asked is something like this: in the series parallel circuit shown in the figure, find the total resistance of the circuit, and find the second subdivision is find the total current flowing through the circuit. So you want to find the total resistance of this entire circuit. Okay, so you want to find the total resistance of this entire circuit. So here you can see that totally 5 resistance are there. So you want to convert this entire 5 resistance into a single resistance circuit. Okay, and finally you want to find what is the total current that will be flowing through this circuit. So this is what the question that has been asked. So to your understanding, finally you will be amazed that this big circuit will be converted to a very small circuit like this. You can see that here R1, R2, R3, R4, R5, 5 resistance are there. So you can see that there are many series and parallel combination of resistance are there. See, these two resistance are connected in parallel, and these two resistance are connected in series, and this R1 is connected in series with the parallel combination of this and series combination of this. So it's a very complex circuit. So this entire circuit can be converted to a 2 resistance circuit which are connected in series. So this can be easily solved. So how to find the total resistance of the circuit? It is nothing but just R1 plus this R equivalence. Okay, this is what. So that is R1 is nothing but rho. So this entire circuit will be reduced to this. This is R equivalent. Okay, so this is what we are going to achieve today. And finally, the total resistance will be the answer I am giving you, that is it will be 6 ohms. Okay, so because R1 is 2 ohms, the R equivalent of this particular circuit is nothing but 6 ohms. So this is what we are going to try today. Okay, so now let us go into the solving. Okay, so you can see that. So this is the question that has been given. This particular circuit is given with 15 volts as input. So R1 is having 2 ohms, and R2 is having 30 ohms, R3 is having 60 ohms, and here you can see that R4 plus R5. Why I have combined this? Because so here in the circuit you can see that R4 plus R5 can be added together. Why it can be added is because it is connected in series. So if it is connected in parallel, then the equivalent resistance is 1 by R equal to 1 by R1 plus 1 by R2. So if it is connected in series, then it will be R4 plus R5. So that's what I have done. So what is R4 plus R5? So 3 plus 2. So 3 plus 2 is nothing but 5. So this is what has been written over here. So the next step is, so you can see that these two resistors are connected in parallel. Is it right? So how to find the equivalent resistance? So you can see that the equivalent resistance is 30 into 60 divided by 30 plus 60. Is it right? So this is the formula for the resistance that has been connected in parallel. So R2 into R3 divided by R2 plus R3. So 30 into 60 divided by 30 plus 60, which is nothing but 20 ohms. So here I have written this particular branch as 20 ohms and this particular branch as 5 ohms. So now you can see that these two resistors are connected in parallel. So how these two resistors are? So you can see that when the current is entering after going in R1, you can see that the current is getting divided. The current is getting whenever the current is getting divided between the two branches, then you can say that the circuit is connected in parallel. Whenever the same current is flowing through that particular circuit, then it is connected in series. So you can see that when this is positive and this is negative. So from positive supply, the current is crossing this R1, and after which it is getting divided into two parts. So these are connected in parallel. So now you have to do again 20 into 5 divided by 20 plus 5 is the equivalent circuit of this. Okay, so you can put 20 into 5 divided by 20 plus 5, which is nothing but 100 divided by 25, and which is nothing but 4 ohms. So the entire circuit now has been simplified, as you can see that this is the most complex circuit which has been given initially. So how to solve it? So you can see that the entire circuit has been divided as to 2 ohms and 4 ohms. Is it right? Because you can see that the equivalent resistance is now, so the equivalent resistance of 20 ohms current in parallel with 5 ohms is nothing but 4 ohms. So here I have written the 4 ohms. So finally you can see that 2 ohms and 4 ohms are in series, and that will be your 6 ohms. Okay. So it's very simple. So similarly, so now how to find the total current? So total current will be equal to voltage. What is the voltage? So as per Ohm's law, voltage divided by total resistance. So total resistance is 6 ohms. So total current IT will be equal to V by RT, which is nothing but 15 by 6, which is nothing but 2.5 ohms, 2.5 amps. Is it right? So the total current given found out as 2.5 amps. Is it okay? So very simple. Hope you understood this. Okay. So now after that we can go to slightly still more of a complex problem. So only if you don't understand the logic behind the problem, it will be quite difficult. If you understand the logic behind the problem, just a calculation and you can simply solve it. So similarly we can solve one more type of problem. So here you can see that the problem has been asked like determine the current delivered by the source in the circuit shown below. So you can see that this particular circuit is highly complex. Oh, this the circuit is looking something like a triangle. See how many triangles are there? 1, 2, 3, 4. Is it right? So and big triangle is there. So totally 5 triangles are there. So it's very difficult to solve this problem. By just looking at this problem, everybody will avoid solving this problem. But once you know logic behind it, this is a very simple problem, and you can easily score the marks, and you can easily find what is the equivalent resistance of this particular circuit. So now let us go into the problem. So here I will say that this particular circuit, so this is a circuit which has been given to you. This circuit can be reduced to the small circuit. You can see that the 30 volt has been connected to this big complex circuit. But this particular complex circuit can be replaced by one single resistance, that is 1.0545 ohms. So how it can be done? How it can be done? Okay, that is what the discussion is all about now. Okay, so shall we start? Okay, so now again you can just go. So you can see that from the circuit, this 2 ohms. So you can see when the current is from 30 volt, the current will be going to the point A. And from point A, the current, you can see that the same current is flowing through both the 2 ohm resistor. So you can see that both are connected in series. Similarly, the current in this 2 ohm and this 1 ohm resistance will be the same. So both can be connected in series. So you can see that 2 ohm and 2 ohm, that will be 4 ohm. And similarly, so this 4 ohm and this 4 ohm will be connected in parallel. So similarly, here you can see that this 3 ohm and this 2 ohm are connected in parallel. So finally, you can see that 4 into 4 divided by 4 plus 4 is what the equivalent circuit of this parallel circuit, and you will be getting 2 ohms. Similarly, these two are connected in parallel. 2 ohm and 3 ohm are connected in parallel because the current is getting divided at this point. So 2 into 3 divided by 2 plus 3 is nothing but 1.2 ohm. So here, when I reduce these two, the circuit will be simplified something like this. And you can see that the current, that is the resistance in the branch AC and the resistance in the branch CD, and now these two are connected in series. You can just add these two. It's very simple. Is it right? So now we will move on. So you can see that when I add these two, you can see that 2 plus 1.2. Is that right? So it is nothing but 2. Here it is 2 ohms and here it is 1.2 ohm. So 2 plus 1.2 ohm will be 3.2 ohm. So after doing this, you can see that these two are connected in parallel. That is 3.2 ohm and 2 ohms are connected in parallel. So how to reduce it? So now you can put 2 into 3.2 divided by 2 plus 3.2. So the entire circuit will be reduced something like this. Okay. So after converting this, you can see that these two resistors are connected in series, because when the current is leaving this point A, the same current, will be flowing through this D and then through B. So you can see that the current will be flowing like this. Is it right? So the same current is flowing through this 1.23 ohms as well as to this one. So these two are connected in series. So now you can add these two. So 1 plus 1.23 will be equal to 2.23 ohms. So now again you can see that these two are connected in parallel. Is it right? So these two are connected in parallel. So you can see that 2 into 2.23 divided by 2 plus 2.23, which is equal to 1.045 ohms. So you can see that so this is the final equivalent circuit which I have promised. So you can see that this particular big circuit has been converted to a very small circuit. So now what is the total current? So total current 30 volt is given. So the total resistance is there, that is 1.045. So as per Ohm's law, the total current I will be equal to the total voltage that is given divided by the total resistance, that is 30 divided by 1.0545, which is nothing but 28.448 amps. So as I promised, you can see that the entire complex has been converted to a very simple circuit. So these are all very simple. Okay, so it's very simple to solve. So hope you understood this problem, and we will go to the third example. So it is quite slightly complex when compared to the previous problem. Okay, so here also the question asks us calculate the equivalent resistance across the terminal of the supply and what is the total current that has been supplied by the source. So only if we calculate the total resistance, then we can calculate the total current. So how to calculate the equivalent resistance of this? So here you can see it's very simple, isn't it? So if you are really clear with the previous two examples, I am sure this is very simple for you. Because see here you can see that these three resistors are connected in series, that is 4 ohm, 16 ohm and 4 ohms are connected in series. Is it right? So you can just add these two and add these three resistance, and after adding these three you can see that equivalent resistance and this 12 ohms are connected in parallel. Then you have to use that parallel circuit formula. Then again you can see that these three will be in series. Then again you can see that particular equivalent and this particular resistance are connected in parallel. Then these three will be in series, and finally you can find what is the resistance. So if it is in series connection, you can just add all the resistance. If it is in parallel connection, you have to go with the cross multiplication of the resistance. Is it okay? So now what I am promising is, so this particular big complex circuit will be connected to a very small circuit like this. So if you have a very small circuit, it's very simple to solve, isn't it? Because three resistance connected in series. So you can just add these three resistance in order to get the total resistance. So then 100 divided by the total resistance will be giving you the total current. Very simple. So what I am trying to say is, at the end of this video, you will be clear of how to convert this big circuit into a very small circuit. So here you can see that. So let us start. Okay. So here these three are connected in series, that is 4 ohm, 16 ohm and 4 ohms are connected in series. So if you add all these, so 16 plus 4 is 20, and again 20 plus 4 is 24. So here I have written this 24 as here. Okay. So now you can see that after converting these, so you can 3 in series, so that equivalent combination will be connected in parallel with this. Is it right? So this equivalent connection will be connected in parallel. So now if it is in parallel, what is the equivalent then? 12 into 24 would be 12 plus 24. That is what is written over here. That is nothing but the 8 ohms. Is it right? So this particular branch now has been replaced with this 8 ohms. Is it right? So this particular branch, see here I have shaded. So this particular branch has been replaced with this small resistance. Is it okay? So now you can see that these three resistances are connected in series. So now we can add 6 plus 8 plus 6. So 6 plus is 12, and again 12 plus 8 is 20 ohms. So that is what is written over here. So here you can see that 20 ohms. So here this has been converted to here, and this is this 20 ohms is there. Okay. So this circuit, please take this circuit. So this circuit. So again you can see that these two are connected in parallel. So if it is both are connected in parallel, how we can solve is 12 into 20, it will be 12 plus 20. So that is what is written over here, and that value is 7.5 ohms. And again you can see that all the three resistors are connected in series. So your final value is 8 plus 8 plus 7.5. Is it right? So 8 plus 8 plus 7.5 is the total resistance in the circuit. So 8 plus 8 plus 7.5, which is nothing but 23.5 ohms. So you can see that this complex circuit has been converted to a very simple circuit like this. So after converting, it is very simple. So how to find the total current? So the total current will be given by total voltage divided by total resistance, which is about 100 is the total voltage that is input, and 23.5 ohms is the total resistance, and that will be equal to 4.2553 amps. Okay. So it's very simple. If you understand, nothing is there. So I hope all the three problems are clear. So in this video I have clearly explained how to convert a complex circuit into a very simple circuit. Okay. And because this plays a very vital role in most of the core industrial applications. So this particular video has given you 3 different examples of how to solve a complex circuit, or how to convert a complex circuit into a simple one. I am sure this video would have given you the basics of circuits, of how to solve. And if you really like this video, please give a thumbs up, and as well, if you have any doubts, you can just give a comment, and if you feel that this particular video will be useful to someone, you can just share it, and as well, if you really like the contents which I post in the channel, please subscribe to this channel. So thank you very much.